everyone. So today we're going to take a look at this function generator made by a name I'm going to mispronounce. Daedalon. They're no longer around. I'll have more on that later. But this is basically for like educational settings, not too complicated. You got your multipliers here, your frequency adjust, level adjust. There's a triangle wave output, a sine wave output, and then on the back there is a square wave output. It does power on, no smoke, which is good. But I think to start, I will, it's also of course missing two knobs, so I'll try to find similar knobs. I'm guessing I won't be able to find them unless I bought a whole nother unit, and then I'm back to square one with one set of knobs with two units. So I'll look for some replacement knobs. But yeah, I'm going to hook this up to my frequency counter and my digital oscilloscope and just see how it behaves and see if anything's wonky. And then we'll crack it open, see what's going on inside, poke around, and yeah, go from there. Okay, so we got the case off. Just two screws, which is nice. Slides up like this. One screw on each side. And there is not much to this. I guess I could unplug it before I go sticking my fingers in there, huh? There we go. But yeah, not much to this. Maybe. Huh. So you got a couple big fat caps. What are these? Sprague. Nice. 15,000 micro. Can't read the other one quite. We've got an LM380N. And when I looked that up, that is a 2.5 watt power amp, audio amplifier. Okay, here's our transformer. And we've got some pots and switches here. What are these? Ohmite. That's an ohmite, that's an ohmite. They probably use a cleaning, maybe a change. This switch I can clean. And I'm certainly going to get knobs. I'll have to measure these and try to get a knobs that match. I've seen a picture. They all should look like this. This is a nice finish. I doubt I will be able to get knobs that look close to this. So either I get close to it for two or I replace all three to make a match. And in the pictures I saw, this knob was circular like this, but it's got the indicator there. So I can go that route. I could go with a pointer. I don't know. We'll see. But they do have the set screws, so I'll have to go with that style. But yeah, I'm sure these pots could be cleaned. But it's really just the board. Transformer and the board. That's about it. Okay, so I've got all kinds of adjustments there. What does that say? So high-low, 50,000, high-low 5,000, high-low 500. Sine, tri, amplitude, 1K, 25K. So I'm guessing I can dial in some stuff. 78L12. And there's not a lot to this. There's a cap down there. You can check that. Big fat fuse. Not a big fan of the plastic here. You have to... I get it, but if I do have to take this off, that's going to be a pain in the junk because I got to squeeze that. Hopefully don't break it. One at a time, pull them out. I probably will have to do that. And then if you can see in the back of the board, there's some wires, of course. I don't see anything obvious, but I can't really see back there. Solder side. Yeah, thank you. That's good. A function generator. Well, that's what it is. So I think I'm going to have to take this board out so I can get behind it and take a look. Probably clean these terminals. They've probably never been cleaned. Same with the front. Or change them out. I don't know how much these run. It does have a chassis ground. So the third wire is grounded. What's this say? Stancor. STANCOR P-8661. 117 volts. 50 to 60 hertz. Insulation test. 1500 volts RMS, assembled in Mexico, 24 volts, so 1 amp out. Okay, so 24 volts, that's what we're running. Probably step down somewhere in here. Yeah, there's not a lot to this. Kind of cool. I think what I'll do is get this board out and start ordering some parts. Certainly the knobs, I'll look for those. If these aren't too expensive, maybe I'll just buy some new ones. I mean, there's not much to them. Okay, so that was actually much easier than I anticipated. These plastic standoffs right here, you just gently squeeze them and slide the board out. And these are not, the back terminals here are not soldered directly to the board. Interesting though, these are turret style, and then these are more flat blade style. You think they go with the same just for continuity and cost wise, right? Order 10,000 of one instead of 2 batches of each. That's interesting. I wonder why they did that. Anyway, this is all hardwired, so I'm not moving this very far. But here's the board. Ooh, geez, gunky. What is that? That's the LM chip. That's hard soldered in right here. So maybe, and you can see, maybe you can see. Let's see here. If I can get this out of the way. You can see how gunky that is. I wonder if that has something to do with our problem here. It could be flux. It looks like flux, but they certainly used a whole heck of a lot. This ground wire is just soldered onto this plane here. I can't see that. Which I guess that works, but if you're going to go here, just go to the post, right? I mean, it's all... That seems like a layup. I don't know. Yeah, they've got some of these wires just right onto the board. Nothing seems too loose-ish. But certainly needs an alcohol bath. I will clean the heck out of this thing. This especially. There may be some... You can see the coating is starting to bubble there. So I'm guessing this is... Something's going on here. Maybe I don't necessarily replace this, but I desolder everything, clean it up, put it in a socket for future maintenance. This one's not nearly as bad. Still dirty, but not nearly as bad. This whole thing needs a cleaning. I think that's where I start, is just the cleaning, because that could work wonders. Oh, this is... Okay, so they've got it soldered through. Yeah. Check these 3 caps total, I think. Is that a cap? Yeah, 0.47 micro at 50. This was the 15,000, and then, can I see this now? What is this? 4,700 micro. Big fat sprog. Yeah, so I think that's my to-do list, is clean this up. I might desolder this chip. I'll see how much a new one is, just for fun. Maybe, if they're in stock, probably a couple cents. Maybe put a new one in there. I've looked for documentation. I didn't find any, but I'll keep looking, because it does have these pots here. And they are labeled, like I said, high-low 5,000, high-low 500, high-low, sorry, 50,000, 5,500, and then sine tri-amplitude, 1K, 25K. So I imagine there's a procedure out there somewhere to adjust this. We changed out this pot here, and this is the old one. I don't know if we can see. It looks a little crunched right there, like it took a hit, like downward, you know. So I don't know if that had any effect on the knob. I think it did, but in any case, we got our new one in here. And I've got new knobs. So I'll show you the old one. This thing only came, as I said, with just the one right here, which was this one. And I got new ones, which are almost identical, and I'm super stoked about it. So, old on top, new on the bottom. Just about the same height. The pattern, the grip there, this one's a little wider, but I mean, that's marginal. But yeah, same marker, same color, both 1/4 inch. So let's see, once and for all, it's only taken a few times, if this bad boy will go on there. So this is bang left. Okay. Well, it certainly fits, but let's just see how she behaves. Pretty good. Let's see about the other one. This is the second new one. Let's see. That's all the way up. So I want to line that up. I want to line my marker up here with 100 as best I can. Let's hope this is easy to get to here. I need to get on eye level with this thing. Steady. There we go. Without scratching anything up, hopefully. Yeah, so the same problem. So you can see, maybe it's something I'm doing, but you can see if I turn this, see how much further out this one is? That's super annoying. This one's flush, basically, all the way up against it. And this one, the depth of the knob is the same, I believe. Am I going crazy here? Yeah, that's the same depth. Here's the old knob. Let's see the old pot and the old knob. Yeah, I guess that's true. The case for all of them. I don't know. This is strange. Unless I installed it wrong. I don't think I did. It's one washer and a lock washer. I guess that would be more like that. Yeah, it's a little out more on the new one. It's also split knob. This one is not, but that shouldn't matter. Huh. So I can put this one on as far as it'll go, of course. Where am I at here? I'm being fully right. Try to get this all lined up. And then fully left would be, that's close. Let's see here. So fully left, off, fully right. That's pretty good. Oh, there we go. Fully right. As far as the angle, you know, I'm being very nitpicky now, but as far as the angle goes, that's pretty good. This one, I think the dash lines up pretty well. 10,000, 1,000. Be nice if that was level, right? And 100. It's just that it's way in. So maybe I can just not install it all the way on and try to match this one. All right, no, I already forgot which one I'm at. There's 100. Let's see here. Of course, it's right where that other knob is. That's a little better. That I can live with. It's just, man, look at the difference there. One sticks way out, the other does not. Yeah, I can only come out so far. Or it gets crooked on there, and I do not want that. I'm going to live with it. I'm tired of looking at it. 100. Well, I'm wrong now. Oh, jeez. Way off. There we go. That's pretty good. So the piece de resistance is this new knob. So I like this a lot because I got a wide path here, right? So I did try this one before, which is a good looking knob. Got some nice feel to it. It's so big that it actually covers up some of the text there, frequency and hertz, which you can make out what it says, but Yeah, so I think I'm going to use that one. I've also got this one, which could work just fine. A little smaller. Doesn't really match this. I mean, it's silver, but now I got a white line and a black line. So, again, being super nitpicky here. This one's got the silver with the black line. It's also got a nice pointer. It's almost all the way up, which is nice. The only issue I'm having now is getting this so it's like this one, because it's, you know, it's about 300, and I think they said 15 degrees or 20. Get it to line up, get my angles, you know what I mean? So let's just see here. Let's loosen that up. I am banged fully counterclockwise. Yeah, see, it hits the red here, but it does not hit the black there. And as far as I can tell, there's no there's no happy medium. So now this is a little closer to the black terminal, but I'm still banging on the right one. That's frustrating. Let's stay here and move it up a little bit. Just a little. Nope. Yeah, so I think I'm just going to have to live with that. It's actually not bad as a stop, right? It should be stopping there anyway. I'm curious if I'm losing some travel. You know what I mean? Is there more spin after that? Oh, like a nudge, just a little bit more spin. So that is fully clockwise. Boy, if you ever wanted to watch some dude struggle with some knobs, well, don't Google that, but this is the channel for you. So that's fully clockwise. And now it's going to bang on the right. Yeah, I got a choice here. Oh, actually, it goes past it. I'm out. I don't know that I like that, though, right? Because now I'm going to hit, if I'm plugged in here, I could hit my plug. I could damage that. So maybe I push it in all the way. And that way, it does hit the terminals, but it stops there, right? And I'm not going to, someone's not going to come along and crank on this and then damage the plug that's plugged in the front. So, oh, woof. Who knew knobs are so difficult? This should not be this difficult, right? So that's fully clockwise, I hope. And it hits on both, so it's kind of even. I might lose, you know, a tenth of a tick there, but it's just hard to tell if it's actually spinning. You know, I don't have I guess I can put a meter on there. Let's find out. Let's make sure I'm actually turning the pot and not just spinning the knob around the pot. Give me some good clips here. Some good clips, please. Let's see. So we've got black, red. I'll zoom out a little bit. Yoink. And I will clip these on the pot. Let's see what we got here. Oh, come on now. Stay with me. 932K. Did not change. Well, that's not great. Let's try this terminal. 9.932K. Okay, that's the one. So low setting, 1.1 ohm. That's pretty good. 473 all the way up. What's my high setting? Probably supposed to be 1K, 1 to 1. That's my guess, but I'm going to live with that. Again, this is an education tool, and I'm not building a space shuttle, so that's good enough. Good's enough. Okay, so too many cables. Cables everywhere. So I'm going to power up this bad boy. So quick update here. That email I sent to Science Direct, they got back to me pretty quickly, the next day actually. And as you can see here, they kind of give the skinny. Science Source in Maine was produced by a Science Source in Maine, and Science Interactive now, which is who replied, acquired them in 2014. The EG-01 has since been retired and purged from our system. We no longer have any information regarding the product. She did send another one sheet PDF on this other function generator. It's more of a sales pamphlet-ish. The data sheet. There's not much to it. But it was nice that they got back to me right away. They didn't have to do that. So Catherine at Science Interactive, thank you for doing that. As for me, I'll keep looking. Maybe, I'll find something out there. It is a pretty simple board and system, so I think I can stumble through it. It would have been nice to have, operations manual or service manual or maintenance manual. But I think I can maybe stumble my way through it. So anyway, thanks again, Catherine at Science Interactive. All right, so the very low end, times 100, bang, counterclockwise, I'm at about 27.8 hertz. 0.8, 0.9, 0.7. If I turn this up, we'll hear it first of all. And the high end is 975.2. So now we'll go back down. We'll go to times 1000. And the low end is 950 hertz. 48, 52. It's a nice overlap, and we'll crank it up. And we're at about, 14? 14.5 kilohertz. So that's middle, that's times 1000, bang clockwise. Finally, we're not going to hear this. This is times 10,000 at the very lowest. 14.5. And if we crank it up, what's our max? We start to get a really ugly signal there. It's supposed to be a sine wave. And we're at about 117K. Let's try triangle wave. That's even uglier. Same frequency though, ish. But that starts to look a lot better when we bring down the frequency. It starts to dial in. I think that's the limit of that chip, right? That's a much better triangle wave. Even though we've got these peaks, these dips, whether it's a sine wave or a triangle wave, that's okay. Bring this down. We'll turn that down. Excuse me. Sine wave. You can see it walk across. And then times 100. So that's pretty cool. I'm happy with that. Again, just an educational unit. Not terribly high tech, just really one chip in there. One generator chip and one amplifier chip. And some conditioning, but that's pretty cool. So, yeah. Thanks for sticking around. I'll button this bad boy up. I might paint the top black. It is black, but a little chipped. Buy some spray paint or something, but thanks for watching. Like it if you like it. Subscribe if you'd like. And I'm going to let this play me out. Let's do... I'm just going to turn this off and let this collapse. 3, 2, 1.